So today we are actually going to be talking about slab detailing, how to actually detail your slab. Okay, so I'm going to be doing some of the panels. I will demonstrate some of the panels for you, and then you're going to see how to actually detail your slab. We have an existing drawing here. I'm going to explain from this existing drawing, then I'll practicalize it in this our drawing that we are working on presently. So you can see from this slab here, this particular panel. Let me forward this. Good. Now you can see that from this existing drawing, this is a two-way. This is two-way, two-way. This is one way, this is one way, this is two-way, this is two-way, this is also a two-way slab. Okay, so for here that we have a two-way slab, you can see this in two directions. This is coming like this one is also coming this way. That is, they are coming in two directions. That is what two-way means. So we are having our main reinforcement here. We are also having another one here. So this is exactly what that two-way means. Okay, you can see a main reinforcement here. You can see we have another main reinforcement here. Okay, the same thing goes for every other two-way slab. It is that way. Okay, so when you come to your one-way slab, you are actually having your main reinforcement going along the short span. Okay, along the long span, you can decide to provide a minimal reinforcement. That is a reinforcement that is not is actually not the main reinforcement. Okay, I'm going to show you that. If we come here now, look at this reinforcement. For example, this is a call out. This is the call out for this reinforcement. Now,
hello, can you hear me?
Yeah, I can hear you. It seems like you have fixed your...
Thank God.
Or you have gotten another laptop.
No. I went to fix it this morning.
Okay, good. It's all right.
Okay. Thank you very much.
So, talking about this is a one-way slab from the slab and beam layout. This is telling us that this panel is a one-way slab, which is what we have here. This panel, this panel, this panel, this panel, they are all two-way slab. Okay, this, while this and this, they are one-way slab. So I was explaining, you can see that we have our main reinforcement here. If this reinforcement is being called out here, you can see Y12. While this other reinforcement, which is this reinforcement, this is called out here, is also Y12. While when you come here, you are going to see that this reinforcement along this long span, this reinforcement that is long, if you go to this call out, you discover that it is Y10. Okay, I was explaining the reason why we have a one-way slab. Our main reinforcement is being spread along the short span. So along this short span now, you discover this is the reinforcement here, and this is the call out for this reinforcement. Well, this reinforcement actually starts from here. It comes to this place. But in this area now, you discover that this reinforcement, this is an arrow here showing you that this reinforcement spans with these donuts here, telling you that this reinforcement spans from here to this place. Okay, it's actually a bit complicated. You have to sit down and study it very well. If possible, go through what I'm showing you today and watch over and over to have a deeper insight of what I'm trying to explain. So this reinforcement now that I'm talking about, you discover that it is actually a Y12, but the other long one is Why 10? Because this panel is a one-way slab. But in two-way slab, you are having your main reinforcement in both directions. But you can see here now, we only have our main reinforcement in one direction. That is the reason why it is called a one-way slab. Then the other one is called a two-way slab. Okay.
Okay.
Yes, and I have explained how you can get your one-way and two-way by a simple calculation. When you do your Ly over Lx, you'll be able to know whether it is a one-way slab or is a two-way slab. So in a case where you have a one-way slab, your main reinforcement are spanning along the short span. Please take note of that. For two-way slab, you are having your main reinforcement on both span. Now,
okay, hello, sorry. Hello.
Yeah.
Okay, you said that in one-way slab, main reinforcements part on in the shorter
along the short span.
Along the short span. Okay, all right. Thank you.
Along, this is the short span now. From here to here is the short span. Here is shorter than here to here.
Yes.
So we have your main reinforcement, which is this, is spanning along this short span, going this way. So this is the main reinforcement, which is Y12.
Okay, sorry, but on that one-way slab, there is another reinforcement.
Where is it?
That this one, this blue one.
This one?
No, the other one. Yes, this one. Yes.
One. I've not come to that yet. This is a top distribution bar. Just calm down. Let me explain them. Let me finish explaining. If you have any challenge, then you can ask. I'm going to explain every reinforcement that you see here. There is no magic. I will explain each and every one of them.
Okay, sir.
Then you have your main reinforcement. You have your return. This main reinforcement will always return back into the slab. This is the return. The return is 1/4 of the span. For example, from here now to this place, which is this length from here to here, is actually 3,730. If you do 3,730 divided by 4, that's 1/4. Whatever value it gives you, that is the return you will return here. Do you understand what I'm trying to say?
Yes, sir. Yes, sir.
So for this span as well, from here now to here is 3,530. If you do 3,530 in your calculator, divide it by 4, that will be the return that you will return for this one as well. Do you understand?
Yes, sir.
So when you are doing your detailing manually, sometimes if I want to make my work a bit faster, I don't have to start measuring the return here. You understand? I don't have to measure that return here because of probably maybe time. But if I arrange this by eye, you discover that this is almost 4 times. Where is that this thing? Almost 4 times. Okay, so that's that return. So that's how it is being gotten. It's not just returning anyhow. What you do, okay, let's do it real and see. 3,530 divided by 4. If you punch that in your calculator, 3,530 divided by 4 is going to give you 882. So if I offset 882, so this return is going to be around here. Do you get the point? So this is the return. Seems like you don't understand my point.
No, I'm following you. I'm following you.
Okay. The same thing with this return here. All you need to do is to take the measurement from here now to this place. Sorry, I think I made a mistake here. This is supposed to be 3,730. I took this other one. So
Okay.
this from here now to here is 1/4, which is, if I offset, I think that distance is still there. Good. You can see this one is very much closer. So I just shifted a little. So for 3,730 divided by 4, you are going to have 932.5. So if you offset 932, or let's say 933, enter, you offset here. Good. You can see I have to stretch this a bit. So this drawing was done just by ranging it by eye, you know. So they did not really take that measurement here, but that is how it is. The return, when you are doing it practically on site, it has to be divided by 4.
Okay.
Yes. So it's divided by 4. Then that question you were asking about this line, that is why you see these lines. This one is dash line. This one, you have it as a normal continuous line. Then at this point is dashed. It's just a way to differentiate them so as for you to understand, to be able to easily interpret it.
Okay.
That's why the lines, you see that they are not the same type of line. Okay. Yes. So you will now see this other one they use for calling out is a bit lighter. It's not as thick as this one. It's just to give those lines difference so that by the time you are interpreting, it will not be difficult for anyone to interpret. Do you get what I'm trying to say?
Yes, sir.
Exactly. So this one is called the bottom bar. Okay. This main reinforcement is called the bottom bar. This is also bottom bar. You know, this is a two-way slab. So this is bottom bar. This is also a bottom bar. But it returns when it gets here, it returns. Because if you don't return it here, it's going to go outside. You don't have any panel here, so it has to return inside.
Okay.
Aha. The same thing here too. There is no any other panel here, so it has to return inside. But if you check here now, you discover this same reinforcement did not return here. It went into this other slab because you have a slab here. So you don't return it. You just take it into that slab.
Okay, I want to ask the question, sir. Can I ask a question?
Yes, I'm with you. I'm with you.
Okay. This main reinforcement that is extending into the other slab.
Yes.
And the second slab that is extending into as another reinforcement, continuing, that overlap, does it have any specified length? Can it extend into the other slab, or will it stop at the beam?
Which other slab? This one?
Yes.
You mean extend to this place?
Yeah. Is it going to stop at the beam or extend into the other slab?
Look at where I stopped it here now. This
Okay.
is the second slab here now. This one stops here.
Okay.
This is another reinforcement different that is coming across here. This one, they overlap. This one and this one overlap with each other.
Okay.
But in a case where you don't have this, you can see this panel. That is why this detailing, two detailers cannot detail drawing exactly the same. And being that your detailing may not be the same, but it may also not be wrong. The same thing with design. Two engineers, when they do their design, one will definitely be more economical than the other. I have stated this before.
Yeah.
So it boils down to your years of experience on site, on design, everything incorporated together. So the more you are growing, the more you are having a deeper insight. Okay, so if you give this detailing to another engineer who has been doing detailing for years, he may not detail it exactly, but his detailing may also not be wrong. Now, to answer that question, this reinforcement can also span even across this one, but it has to overlap. When it hits a beam, it has to overlap. It has to cross that beam. I cannot leave it here. It will fail. Sorry, there's another reinforcement here, so that's why it's looking like. Let me shift this reinforcement a bit. You can see there's another reinforcement here. So this one now, I cannot leave this reinforcement here. This is a beam here, so it has to go across it. So by the time I place this reinforcement like this, there will be no need for this one again.
Okay.
Is it making sense? But the way I'm teaching you now is the best way for you to easily understand. Learn it this way first. As you are growing in it, you are having a deeper insight, you are understanding better. Learn it this way is the best way to learn. If I show you now to cross this one to this side, it's not wrong. But I don't want you to learn like that first.
All right, sir.
Learn it this way. Just imagine that it's breaking here, then another reinforcement will break. Because every reinforcement, they have their entire length. It's usually 12 meters. If you check the length of reinforcement in market, I think it's 12 meters, if I'm not mistaken.
Yeah.
12 meters. But now it's not even up to 12 meters anymore. I think it's around 11.5 or so. It's not exactly 12 if you take your tape to measure it. So it's a bit deep, okay? But learn it this way. Once you understand it this way, you don't have any other issues. You can just look at other people's drawing and you understand. You get it?
All right, sir.
Yes. If you check Oyenuga book, I think there is a way he did one particular, because I was just flipping through one time like that. I cannot remember. It's been long though. And then there is 2 panels like that, that this reinforcement, he just drew that reinforcement and it crosses up to like 2 panels, I mean 3 panels. So there is nothing wrong with doing your detailing that way. Like I said, reinforcement have its entire length. So by the time you span a reinforcement and it's going above even a 12-meter span, you know, if you sum up this plus this plus this, you know that is around maybe 9 meters or 10 meters, everything here. So this reinforcement will most likely not be able to span this entire span, because you also need to return. Am I making sense? Because the reinforcement will have to return inside, where you don't have a panel here. This is outside. This is outside. It must return back inside. This is also outside. It has to return back in. So please learn it this way for now, or else you are just going to be confused about everything I'm doing.
Okay.
So this is another panel here. The same reinforcement that we have here is the same, only that this span is a bit different from this span. But these are both two-way slab. And this one returns here. I believe you understand why it's returning back now. And then you have a top distribution bar. This is a top distribution bar. It's on top of that your return. So that this slab detailing, you need to visit the site to have an insight, or else it's going to be like a magic.
Hello, sir.
Can you hear me?
I can hear you. Can you hear me?
Have you been on site before?
Can you hear me, sir?
I can hear you. Have you been on site before?
Yes, presently there's a site that's okay. So where I had my training is a construction company, and they have a training department. So
and
after we have trained, Yeah, they take us to sites.
Okay, fine.
Yes.
All right. So you must have seen on that site where a reinforcement return.
Yes,
Good.
I saw it.
So that is what we are doing here now. And then on top of that reinforcement that return inside, it's going to look like this. If you are seeing it,
Yes, I can see you.
you are seeing my hand, Abby. It's going to
Yes, I
return
can see your
something
hand.
like this. And then at the top of it, there are another reinforcement that is on top. That's the top distribution bar.
Top distribution. What's the significance of that top distribution bar? What's the function? What's the job?
If you leave your reinforcement return like this without putting anything, wouldn't it be flappy like this?
It will be flapping.
Uh,
An engineer told me that one of the function of the top distribution bar is that the moment is to help redistribute the load on the slab.
is to what?
To help distribute, to spread out the load on the slab, on the beam, sorry.
That is why from the name, what is the name? It is called a top distribution bar. So as the name implies now, is a bit deep. If I want to go into explaining some of the functions of your reinforcement that you have on tension, on compression and all that, is a bit deep. That's why I'm always encouraging you to lay your hands on some of those books so that you have much more insight to what I am doing. Okay, but the top distribution bar, I just want to use a layman language. By the time you return your reinforcement like this, if you don't place those distribution bars on it, it will definitely be flappy like this. So there's no way it can stand. And if you check that top distribution bar, it always goes just like he said. Okay, so it gives it a stability around there. You know, it will hook inside your reinforcement from your beam. It will go inside and then it will return back. Then that's your reinforcement that returns, I mean. Then you now have your top distribution bar at the top of that return. My brother,
I'm following you.
Okay,
I'm following you.
Fine.
Sir, hello, sir. Hello, sir.
Yes, I'm with you.
No, the good thing is that I, like you said, I visit sites. There's this site we are working on Redeem Camp. It's a very huge project. So I'm seeing all these things real life, how they are arranged. So it's helping me facilitate fast. Yeah.
It's all right. So I'm happy to hear that. Okay. So I have shown you the bottom bar. I have shown you the top distribution bar. Then the next thing I want to show you now is the top bar. This bar goes along where you have your beams, just your internal beams. You can see this reinforcement here now is not here. It's not here.
Hello, sir. I have a question, sir.
All right, I'm with you.
Okay, on the slab, you know, we have the main support. That's the span support. There are two in both directions, in the shorter side and the longer side. Both of them, are they called the bottom bar, or is it called top and bottom bar?
Which reinforcement are you talking about?
I'm talking about
I just stated it just now. I told you this is a bottom bar. This is also a bottom bar. They are both bottom bar.
Okay. That's what some people call one, because one will be top, one will be at the bottom. So some people say this one is top bar, this one is bottom bar. So it's confusing. I just want some people will tell you the two, one is top, one is bottom, because one is on top of each other. So I want to get that clarification. I understand what you are saying.
You are talking about bottom, top. My brother, don't disturb your brain. So bottom, top. See, just learn it like this. Don't complicate issues for yourself.
All right, sir.
I understand what you are trying to say. Just allow me, let me finish, then you can ask your question, or else we'll keep going back and forth.
All right, sir.
Let me just finish explaining this, then you can ask all your questions. This is the top bar. It goes internal along your internal beams. Look at another one. Look at another one. All the areas you have your internal beam. But you can see this one was used, they use one for both beams. So by the time you bring out the 1/4 of this, 1/4 of this, and then at the long run, you may see that there is no much, the space remaining is not that much. So that was why they spread this top bar across the two beams. But it boils down to your, as you are moving in your years of experience, site experience and all that. So you just understand how to make your work much more easier and faster. But you can still break it if you want to break it. So learn it assuming you are breaking everywhere. So you don't have to do it this way. You can just do it the normal way as we were explaining. So, but doing it like this too is not wrong. It's even, so you can still have it like this. So you have your top bar, you have your top bar instead of having it this way. I hope you understand that point.
Yes, sir.
This is entirely the reinforcement on slab, nothing different from whatever I've explained right now. The only thing now is just for me to pick, I'm going to do the detailing practically now on the design that we are working on. So another thing you need to understand for this, again, I have even explained it already. This one is just to know, okay, based on the spacing, what is the spacing for all of this reinforcement, and all of this spacing is gotten from your design. You are not just assuming a value. All right, let's come back here now. All right. So right now I'm going to pick, like I said, I'm just picking directly from the software. Now, maybe there's another thing I did not explain. Sorry, is cantilever.
Okay.
Yes, this is a cantilever. Okay, so wherever you have a cantilever in this design, this is a cantilever. You can see that this reinforcement is not represented like the other one, like this ones. You can see this one, the return is just 1/4 here. But when it comes to cantilever, you can see you have this reinforcement. It enters here, but when it's returning into the slab, you can see the return enters here and also goes into the slab 1/4.
Oh, okay.
Do you have a confusion with this?
Not exactly. You are saying that the reinforcement on the cantilever, if it spans the length, it will now return, it will move past the cantilever, go to the nearby slab, and enters by 1/4. Is that what you're saying, sir?
Exactly. So by the time you measure the distance from here to here now, divide it by 4. So this is the 1/4. So you can see the return is longer than the main bar that is bottom.
Yes, sir.
All right. So it returns inside this way. So that is just one point I wanted you to understand. All right. So if you understand this now, then you don't have any other issues with slab. Right now, I'm just going to be doing it practically from the drawing we already have. So you can see I'm just copying from existing drawing to do my slab detail. Here now I have just 9 minutes more. Don't worry, we are going to do this calculation and do it the right way. We'll put this reinforcement the right way. We'll take 1/4. So we are not going to do the Wururu method. Then we are going to design some few panels. We'll design this one and this one. So whatever we do here and here, we can reciprocate it for any other panel. It's the same thing. We are just repeating the same thing over and over and over again. It's the same thing you keep on repeating. So you always put your top distribution bar. Okay, let me put my top bar. Because this is an internal beam, I have this. I will take the right measurements later in the next session. I just want to place all the necessary reinforcement where they are supposed to be.
All right, sir.
With the site experience you have, you are definitely not going to have much problem with this, because you have a lot of problem when you are trying to explain slab to somebody who has never been to site. You're going to have serious problem because slab can be a bit tricky. All right, I'll save this here. Then I'll pause this section, and then on the next section, I'm going to be explaining based on, I have even explained them already, so but we are going to do it practically in order for you to see it practically, how the span, the spacing, and all of that. You're going to see all of that here in the next one. But before I go to the next one, you can see this reinforcement is entirely inside. So I'm not returning anywhere. You can see it's not returning here. It's not returning. It's not returning. It's just coming this way. It's different from the other one. It's different from this one. You can see this one returns, but this one is inside entirely. So it's not going to return anywhere, because you have a panel here, you have a panel here. So you have this top bar here also. So this is it. So I'm going to be explaining it deeper on the next session. I hope I recorded